Hello students, good morning. Welcome to online learning standard 9 subject science. Dear students, in 9th standard science we have been discussing the chemistry part. There the unit which we are discussing is matter around us. And dear students, using the previous video we are familiar with the types of solutions. What is called as solution, how it is prepared, what are the components of a solution, and how it is classified based on particle size. So these are the concepts we have discussed in the previous video. And today, by using this video, we are going to learn about the second type of the solution, which is colloidal solution, and the properties possessed by it. Okay, dear students. So concept of the today's video class is properties of colloids. Students, there is no difference between colloidal solution and colloids. The colloidal solutions can be shortly called as colloids. Okay, there are many properties shown by colloids, but about them we will discuss in a detailed way in your higher studies, which is 11th and 12th standard. But here in the 9th standard you are going to learn only about two properties, and those two properties are Brownian Moment and Dyndal Effect. Okay, students, so what are the properties we are going to discuss now? There are two properties, those are Brownian Moment and Dyndal Effect. Okay, ma, let us have a discussion on these topics one by one. First, we can study about Brownian Moment. Dear students, first you have to be familiar with why this property of this colloidal particle is called as Brownian Moment. The meaning of the name you have to be familiar. Listen here. This property of colloids is discovered by a Scottish scientist or a Scottish botanist, and whose name is Robert Brown. So, in the memory of him, this property is termed as Brownian Moment. So, what is the meaning? Why this property is named as Brownian Moment? Since it was discovered by a Scottish botanist who is known as Robert Brown, and this property is named after him. Okay, and so this property is called as Brownian Moment. Now let us see what is called as Brownian Moment and why this property is shown by colloidal particles. Look here, students, in the first picture what I have taken, I have shown the preparation of a colloid. Here starch is taken and starch is dissolved in water in order to prepare a colloidal solution. That I have explained in the previous video. When starch is dissolved in water, we get a cloudy, turbid solution, which can be considered as an example for what? It can be considered as an example for a colloidal solution. Now, if you take a drop of this colloidal solution and when it is viewed under a very powerful microscope, what we are doing? First, we are preparing a colloidal solution by dissolving starch in water, and now we are taking a drop of colloidal solution, and it is viewed under a very powerful microscope. What will we observe? That is my question. When a drop of colloidal solution is taken and it is viewed under a powerful microscope, what will be our observation? Look here, that is given in the next slide. When the colloidal solutions are viewed under a powerful microscope, we observe that the particles of this colloidal solution are in continuous random, what is called as random disorderness, which means the particles of the colloidal solutions are moving in an irregular way. Here and there, like that, the movement is irregular. So the continuous rapid movement of colloidal solution is seen when the colloidal solution is viewed under a powerful microscope. This property cannot be viewed with our normal eyes. When the solution is placed under a powerful microscope, we observe this property. Okay, Mama? Okay, so now here I have taken what is the observation of this activity. The colloidal particles are in continuous rapid and zigzag motion. And why they undergo this kind of a rapid zigzag motion? The answer is given here. The reason is given here. It is due to the bombardment of dispersed particles by dispersion medium. Students, we know that in order to prepare a colloidal solution, we need two things. Or generally, to prepare a solution, we need two things. What are they? One is solute and the one more is solvent. And in the case of colloidal solution, the solute is equal to dispersed particle and the solvent is equal to dispersion medium, isn't it? Yes. Now, what happens is when we prepare a colloidal solution, after it is prepared, there is a bombardment. Bombardment means what? There is a collision. ஒன்றோடு ஒன்று மோதுகின்றன. So, when the particles are undergoing a bombardment, when the dispersed particles undergoing bombardment with the dispersion medium, what is observed? The continuous rapid movement of the colloidal particles is observed. That is why we are able to see the continuous movement of the colloidal particles under a powerful microscope. Okay, so what is called as Brownian movement? The continuous rapid zigzag movement of colloidal particles is known as Brownian moment. And what is the reason for Brownian moment to occur? It is due to the bombardment of the dispersed particles with the dispersion medium. Okay, Mama? Okay. Now, by definition, I have written what is called as Brownian moment. So, what is Brownian moment? Read it. The continuous rapid zigzag movement of colloidal particles is known as Brownian moment. Why it is called as Brownian moment? Because it is discovered by a Scottish botanist. Botanist means one who studies botany, he is called as botanist. Okay, so it is discovered by a Scottish botanist. He is Robert Brown, and so it is named as Brownian moment. Okay, Mama. So, what is Brownian moment? The continuous rapid zigzag movement of colloidal particles is known as Brownian moment. Okay, Ma. With this Brownian moment is over, then we have to discuss about Dyndal effect, the second property of colloidal particles, that is Dyndal effect. It is also very easiest one. Look here. In the first picture, what I have taken, here I have taken a salt solution. By dissolving salt in water, I have prepared a salt solution and I have taken it in a glass. Okay, well, now light is passed through it. What we are doing? We have taken salt solution in a glass and light is passed through it. Now, when we perform this activity, we cannot see the light particles in the glass. Okay, the path of light is not visible to us. But in case, instead of taking the true solution, salt solution is an example for true solution, but instead of taking true solution, if you take a colloidal solution, this we can perform in our laboratory and see. Okay, so when a colloidal solution is taken and the same activity is performed, when light is passed through it, look here, in the next picture I have taken the first beaker containing true solution, whereas the second one contains colloidal solution. When light is passed through the first beaker, the path of light beam is not visible to us. We are not able to see the light beam. But when the same light is passed through a colloidal solution, now the path of light is visible to us. Okay, it is due to what? Listen very carefully. Now the path of light is visible to us. It is because the colloidal particles are there, no? Those particles have the ability of scattering the light in various directions. Is it clear, students? When we have colloidal particles in a solution, those particles have the ability of scattering the light particles in various directions. And because of the scattering of light, what is possible? The path of light is visible to us, and this effect is called as Dyndal effect. So, what is Dyndal effect, Ma? When light is passed through a colloidal solution, what happens? The light is scattered in various directions, and this effect is called as Dyndal effect. It's a very simple one. Okay, even if you take oil and if you pass red color light through it, we can see that the entire container will be looking like red color. It is due to what? It is due to the Dyndal effect. It is given by definition. The phenomenon of scattering of light by colloidal particles is known as Dyndal effect. What is Dyndal effect? The phenomenon of scattering of light by colloidal particles is known as Dyndal effect. Okay, Mama? Okay. So, in this video, what are the things we have seen so far? We have seen the properties of colloidal solutions. There are two properties we have discussed. Those are Brownian moment and Dyndal effect. What is Brownian moment? The continuous rapid zigzag movement of colloidal particles is known as Brownian moment. Then what is called as Dyndal effect? The scattering of light by colloidal particles is known as Dyndal effect. Okay ma, with this video ends. You can watch the video twice to have a clear understanding. Thank you.